Background, thank you for joining us today. Thank you for your interest. Today's featured presenter is Dr. Hameed Metghalchi, who is the Program Director. So I'll be handing him the microphone here shortly so he can continue with the session. We hope to take about 40 minutes of your time this morning with a presentation, and we want to make sure and get to your questions at the end. Sorry for that brief pause. Here's the session we're presenting today is on our energy systems program. A couple broader points about Northeastern University. You all joining us today have an interest in Northeastern University. That's why you applied here, and we thank you for your interest. You may not know that Northeastern University is consistently ranked within the top 50 best national universities in the United States, as per the U.S. News and World Report. This year, our ranking is 39, I believe, and in my 8 years working for Northeastern University, our rankings have grown every year by leaps and bounds, maybe more than any other university that's in that ranking system. And so our university ranking is important to us. It reflects greatly on our reputation, says a great deal about the quality of our faculty and of our programs. One of the things that plays into rankings is actually an employer survey. So U.S. News and World Report actually polls employers about their opinions of our graduates. And you can see that employers have very high things to say and very positive things to say about Northeastern University graduates. Northeastern University is also serious about the career success of its students. Our career services function has been cited as one of the best in the nation for 5 consecutive years, as per the Princeton Review. Northeastern University is really a powerhouse of engineering. We've been around for over 100 years. And Northeastern University is famous for its cooperative education program. One of the speakers you'll be hearing from today, or one of the topics you'll be hearing about today, is the Graduate Cooperative Education Program, where students can pursue an industrial position for 4 or 6 or 8 months as part of their degree plan. Okay, let me introduce our next speaker, Dr. Hameed Metghalchi. Let me say a few words of introduction. Dr. Metghalchi has his PhD from MIT, and he's currently the Graduate Director of the Energy Systems Program. Dr. Metghalchi is a professor within the Department of Mechanical Industrial Engineering, and is a mechanical engineer, I think, by trade. So we see some interest amongst mechanical engineers in this particular program. Dr. Metghalchi is a professor in the Department of Mechanical Industrial Engineering, and you can see some of his other background. Professional recognitions include Editor-in-Chief of the American Society for Mechanical Engineers, ASME, Journal of Energy Resources Technology. We have a packed agenda for you today. You're going to hear from Professor Metghalchi. You're going to hear from currently enrolled students in the Energy Systems Program. You're going to hear about the Cooperative Education Program. You're going to hear about an innovative engineering leadership program called the Gordon Institute of Engineering Leadership. Without further ado, let me hand the microphone over to Dr. Hameed Metghalchi.
Thank you, Jeff, for the introduction. As Jeff mentioned, my name is Hameed Metghalchi, and I've been doing research in energy and engineering for many years. Now I'm the director of this program. The whole idea is to provide the best possible education in energy systems that you can get anywhere in the world. So let's talk about the agenda. Here, as Mr. Hengel mentioned, we're going to talk about energy system, about the program curriculum, then will be followed by graduate co-op, which is employment for 4 to 6 months in a local or faraway industry. We have very strong student organization, and one of the students or myself will talk about that. We also have a program which is unique for Northeastern. That's Gordon Leadership program, and then it will be followed by Mr. Engel again, dealing with the overall investment in your degree. So what is separating us from other energy programs? The first thing is the curriculum. We have a curriculum required taking courses in finance and economics. So when you graduate, you would be ready to join any company dealing with energy. And then you have a lot of possible electives that you can take, for example, the public policy, if that's your interest is. So it's a wide spectrum of courses that you can take, and that's usually different from other programs which are mainly technical. Now, the other thing that separates us from other programs is this co-op. Now, if you come here and then after 16 credits, taking 16 credits, you can go to co-op and spend 4 to 8 months in a company, and you learn about the company, the operation, and how to implement the topics that you studied in the classrooms. You also get to know what the policy is, how the U.S. companies they operate. Additional differences we have is the Gordon Leadership Graduate Certificate, which will, there's a program that Ms. Amy will talk about it, but again, that separates us from other energy program, and that deals with the leadership and a challenge project doing with industry. Of course, the last one is we are in Boston, and that's a mecca of higher education in the world. So let's talk about energy systems, what we got. Okay, if you probably are familiar with this kind of information. As you know, there are right now 7 billion people living on Earth, planet Earth, and most likely in 30 years it would be double. So you need to provide energy for all the population. And as the quality of life of people around the world increases, their energy use will also increase. The other thing you need to be worried about is global warming issue as we emit some molecule like a carbon dioxide, and that causes global warming, and it will change the temperature of the Earth, and that would have major effects on the towns and cities next to the ocean because the temperature is going to increase and you'll see lots of fuel. So here you have a list of possible source of energy generation. I think there is no one that you can pick up and say that's what we have to do. I think everything should be in the mix, and you have to try to optimize the efficiency, the cost, and then also the global warming issue. That's what you're going to learn when you come here to get your master's degree in energy system. We're going to talk all the different things about these issues, and then by the time you graduate, you have excellent knowledge in all this stuff, plus finances and economics and public policies. So as I said, the energy system, it's not only technical, it's not only one discipline. You have to learn a lot of different disciplines. For example, you have to know solar energy, wind energy, fuel cell, energy storage is one of the important things. At the same time, you have to learn finance and economics and policy, because policy, every government, every country has a government that's going to pursue some policy, and the experts, people like you after graduation, you should try to get involved in making the policy of the given government, again, to reduce the cost of energy, reduce the pollutants in order to improve the human being life. As I mentioned before, here it is, what are you going to study? You have to deal with all these topics that I put up on the slide. Basically, it looks like a spaghetti, and it's just not one area that you can take and say, okay, I'm going to only deal with technical part of it. I'm going to be expert in energy. You would be an expert in energy, but you cannot have, you don't have the knowledge to implement the changes that you want to make based on the knowledge. So here in this program, there are many subtopics that you take as required courses, and then they have elective courses, then you can choose which one of those that you're interested. So it's a very convoluted situation to really be an expert in the energy, and we do our best that after 2 years or 32 credits, you can be expert in that. Now, let's take a look at the curriculum, and then we follow with admissions. This is the admission, and for those of you who graduate from universities outside the U.S., you need to take a GRE score and some English proficiency test, either TOEFL or IELTS. And in the GRE, there are a technical part, there are verbal, quantitative part. The most important thing for us is the technical part, and we have to have at least over 61%, unless you have other information, other background that very strong, and maybe you didn't do a good job on one-day test. Maybe you're not feeling well on that given test. And from academic side, usually U.S. universities, the scale is from 0 to 4, and many schools around the world have used the same kind of a scale. And we would like to have 3.0, basically a B average, minimum B average to get in. And the last quadrant is important, is the work experience. It's very good, it's really preferred, but not required. Especially some of you that maybe work in the energy sector and you feel that you have to have additional knowledge to be useful. That would be great, having background in some industry and then coming here and to do more study the energy program. Now, the overall semester as required is 32 credits. Our graduate courses are generally 4-credit course, so that means 8 courses if you don't pursue co-op. If you pursue co-op, then we ask you to take a 1-credit course to prepare you to go on co-op, and Ms. Laura Mayer will talk about it. Now, the program is also offered online, and it would be, again, 32 credits. We also have a program that if your background is not engineering, but you're a smart student, have done very well in your degree in non-engineering by fields in undergraduate, I think you're in good shape. You just have to come, and you will take 2 courses to prepare you to take graduate courses. So those 2 courses would be basically math background. You got to take some calculus and differential equation courses, and also some thermal science courses dealing with the energy. But after taking those 2 courses, you get into the main program. If you're interested in the Gordon Engineering Leadership, which we'll discuss later on, they have the 16 credit of required courses, and then as a result, you have to take 1 more course, so the total would be 32 credits of the courses in the energy systems. As was mentioned, if you don't have the engineering background or science background, but you're very good at what you're doing, you scored well on the GRE exam and TOEFL exam, we ask you to take 2 courses, the thermal science courses. After those 2 courses, which also include some mathematics in those courses, you would be ready to get into energy systems program, and then after that, you would take 32 credits to graduates. Okay, now what are the required courses? The first one, as you see, is ENSY 5000. It's a 4-credit course. It's Fundamentals of Engineering, Energy System Integration. And as of right now, Professor Kowalski, who's expert in the energy research, energy education, he teaches the course, he introduces you with different types of energy systems and gives you the fundamental information. The next course we have is EMGT 6225. That's Economic Decision Making. That's kind of engineering economy, and you have to say, okay, whatever you invest on, Does it make sense? Is it, what is the, you could have different options. You have to do economic analysis to figure out what you want to do. The third course is from the business school. It's a finance course, and that's 4 credits. You study accounting and finance in that course because it's very important to have those knowledge when you work for a company. And the last course is a mathematics course, and that makes it ready when you have to study, let's say, courses like a solar thermal energies, a solar arrays come in with different angle, what is the energy input, how do you going to use that energy, either photovoltaic or thermal solar. You need the mathematical background to deal with those problems. The elective courses, as I said, there are 16 semesters of elective courses. It's completely up to you, and find out what is it you'd like to get involved more related to energy programs. There are courses in the business, there are courses in social science and humanities, there are courses in College of Arts and Media. Of course, there are lots of courses in College of Engineering. You pick up those 4 courses to the best ones that you think that's what you need to get study for it and learn more. Now, of course, we have some of our own elective courses in the energy system. For example, we have ENSY 5100, it's a hydropower. You study all about dams and how you can basically maximize the amount of energy that you can take away. ENSY 5200 is energy storage system. There are about 15 different types of energy storage systems. So this course reviews all of them. One of them is the hydropower. That would be a specific course. The reason is, as of right now, 90% of energy stored is using hydropower, and that usually happens next to power plants when they produce more electricity than they need. They pump the water up to the top of the hill, and then when they need it, you open the valve and water comes down and you get electricity. Now, there's ENSY 5300, electrochemical energy storage. These are batteries and capacitors. So the battery is going to become more and more important. There are many different types of batteries, and the course is associated with that. There is a course with the dealing with the power plant design and analysis, which deals with the steam power plant, gas turbine system, automobile engine, combustion processes, and as a matter of fact, I'm teaching the course right now. We have also a course in ENSY 5585, which is wind energy systems, and as you know, there are many places using wind energy. For example, if you study country of Denmark, right now 40% of energy in Denmark is developed by wind energy and offshore wind energy, and that's become very important in some countries. The next course that we're going to put up would be a course in a smart grid, and because you know that is the way everybody's going to move on. The smart grid requires a knowledge of control, knowledge of computer, and that course would probably be available soon. Oops. How do you go back? Okay. Well, here is a sample of the elective courses. I don't know if you can see it, but there are courses in chemistry department, electrical engineering department, overall engineering, mechanical engineering, sustainable building, architect, and of course public policy, and we also take some additional higher order finance courses as an elective. Again, as I said, when you come in, you will take the required courses first. While you're taking required courses, you look into the elective courses possibilities, and after those required courses, you take these electives. You know, as I said, there are many different ways you can pursue your elective courses. You need to find your passion, and you move on and try to learn as much as possible of the field that you're interested in. Okay, I think now we Professor Laura Mayer of the co-op program can talk about the co-op possibilities and where students have been spend their 4 to 8 months of a co-op in the program.
Hi, everybody. Let me know if you cannot hear me, okay? So let me just talk a little bit about the co-op program. Co-op, of course, is an optional part of your studies, as Professor Metghalchi had mentioned to you in his piece. What we do is we work with students to get them prepared to go out on a co-op. There is a co-op preparatory class called ENCP 6000, which is required for all students who are wanting to go on co-op. And in that class, we give you the tools that you're going to need in order to be successful during the application process, as well as how to be successful when you are on the job. If you already have a resume, we will help you make that resume better. If you don't already have a resume, then we will help you build one. We cover cover letters, how to establish a LinkedIn profile. That is something that you can start now, no matter where you end up in your life. But working on that LinkedIn profile is a really good way to get ahead. So those are just a couple of the tools that we work with you on as far as getting you ready. On campus, we have an on-campus jobs database called NU Careers. And after you have been here for a semester and you've taken our class, then you will have access to be able to search for a job. So those are just a couple of the pieces. Go ahead, and Jeffrey, and if you can move that next slide in, that would be great. So a couple of the rules and regulations that we do go over in class is the requirements. In order for you to be eligible to go on a co-op in the United States, you will need to complete 1 academic year, and that is 16 semester hours. After that, you are eligible. So, for example, if you start at Northeastern in the fall of 2018, you would be eligible to go on your first co-op in summer of 2019, providing you took 8 semester hours of coursework per semester. So that's just a little bit of an example. You also need to be in good standing. You need to maintain a 3.0 GPA. And again, if there are issues with that, those are all pieces and parts that we can help you with. So what co-op is it is a way to combine your studies and turn them into successful job opportunities. We call it co-op here because it is experiential. We want you to actually live out what it is you are learning and be able to apply it in the workplace. So last year, I think we had probably maybe 400 to 450 placements in our college, which was awesome. And you can see a couple of the companies over onto the right side here of this slide where we have had some energy system students placed. We got Pfizer, Sistine Solar, which is local, National Grid, which is local and national, Eversource, local and national, Vicor, AP, Alliant Energy. These are just a couple of the places where we have had our students or have our students currently on co-op in the Energy Systems program. We work with well over 120 different active employers in NU Careers. And each time we have an opportunity, we introduce ourselves to new companies and discuss their co-op needs. One thing that the students in the Energy Systems Society just completed was an Energy Systems conference here on campus, where we had many employers participate, which all of that is part of the networking process, giving students more visibility and accessibility. So there's many things that we do to give you guys the best opportunity possible. We want you all to have co-op, and we hope that you all can get a co-op. Always there are requirements, and positions are never guaranteed. And just one final piece on this slide here, you can see that there is quite a range in the hourly salary. Students can work, usually between $18 and $35 an hour. So that's some of the pieces and parts that our students have been able to experience when they come to Northeastern University and they go on co-op. And incidentally, if you have any questions, please use the chat box and I can respond to any of those questions for you. So another piece of the puzzle as far as what the co-op advisor role is, as we function as your instructor, we teach your class, we function as your coach, and just kind of give you tidbits and pieces of encouragement along the way. We are your partner as well. We work with you. If you are struggling with something, you just can't quite work through it, we will be right there and we'll have you come in and we'll sit down with you and, you know, really give you the most opportunity possible. And sometimes we're motivators. I know as a mom, I tell my students all the time, you know, and I ask them, I said, can I talk to you as though, you know, I was your mom, as though you were my child? This is what I would say. And so we really, you know, give you some true hands-on support when you are here in our program. There are, I think, 7 of us right now in our department, and I primarily manage the energy system students, but oftentimes we trade and we share and we collaborate with others to, again, give you the best opportunity when you're here.
Thank you, Laura, for that overview of the cooperative education program. The way I like to present it to students is, if you are accepted to Northeastern University and you pursue your energy systems program here, not only do you have the faculty, the support of the faculty, support of staff, but you have the support of the co-op faculty to assist you in your success. And that the opportunity to participate in a graduate co-op program is very unique to Northeastern University. We have several other speakers that you're going to be hearing from today. Our next speakers are either one or more currently enrolled students in the Energy Systems program. I haven't spoken with them yet this morning, but I'll be controlling the PowerPoint presentation from my end. So I'll go ahead and turn the microphone over to our currently enrolled students in Energy Systems so they can give you a little bit of a sense for what the student experience is in the Energy Systems program.
Sure. Thanks, Jeffrey. Hi, my name is Rishabh, and I'm a graduate student in Energy Systems here at Northeastern University, and I was also the president of the student organization for the year 2016. We do have a student organization specifically for the energy program. It's called the Northeastern University Energy System Society, and I'll give a brief overview of why the society exists and what it does. So as we all know, and a lot of people have mentioned, that energy industry is rapidly growing and it's innovating at an amazing pace. And so what it creates is, it creates a big gap between, you know, how academia works and how industry is currently working, because things are changing so rapidly. So the society tries to bridge that gap. We organize a bunch of seminars, field visits, our flagship event, the Energy Conference, which was apparently last week, in which we connect the students with the professionals and the corporates, the people who are actually out there in the industry, so that you can interact with them and see that, you know, what's going on. And what that does is it not only updates, you know, your knowledge about the subject, but it also gives you a perspective of what kind of courses and electives you want to take when you get back to school. So there are 2 ways you can be associated with the society. One, by being a member, in which you can, you know, just show up to the events, absorb all the networking, make connections, learn new things. And the second, by being in the leadership position of the society, where you are actually an organizer of those events. So you get a chance to speak with the professionals, the industry guys, the administration of the university, and you know, learn the natural management skills that are required to pull up those events together. So it's overall a complementary experience to your grad school experience. And I guess that would be, you know, good for an introduction. But if there are any more questions, I'd be happy to address them. Back to you, Jeffrey.
Thank you, Rishab. You know, one of the pieces of advice that I always give prospective students is that when you're investigating a program of study, you want to talk to the faculty, you want to talk to the staff, but you definitely want to talk to currently enrolled students in the program to get their perspective. So Rishab has been a current student in the program for a while, and he's an incredible student leader, and you can see all the wonderful things that the Energy Systems Society is doing. And this is in addition to all the things that we've discussed so far: cooperative education as an option, and of course the substance of the Energy Systems program. With that said, let me say a word of introduction about our next topic. The Gordon Institute for Engineering Leadership is a unique leadership development program. It only exists at a couple universities around the United States. And it's a really excellent life-changing experience for their students. It's a competitive admissions process. Students have to be admitted to the Graduate School of Engineering, and then they have to submit a separate application to the Gordon Institute for Engineering Leadership. Here to tell you more about that program is my colleague in admissions, Amy Manley. We must have experienced a bit of technical difficulty with Amy Manley able to join our session today. So we're gonna bypass the Gordon Institute for Engineering Leadership topic for now. But if we solve that technical problem and they're able to join us, then we'll talk more about that program. As I pass through the slides here, I'll just say that basically, a student who's interested in leadership development is going to benefit greatly from this program. It is a program where you'll substitute essentially half of your technical courses in engineering or in the Energy Systems program for leadership type courses. So you still graduate roughly in the same time frame, 2 years or 2.5 years, but you put significant focus on leadership development. Okay, let me say a couple words about investing in your career. Pursuing your graduate degree at Northeastern University is an investment of time and energy and money. And in terms of tuition, for this academic year, our cost per credit hour is $1,523 per credit hour. Depending on the program that you choose, that could be either a 32 credit program or up to 40 credits, once again depending on your degree plan. So you can get some sense for what the tuition costs will be if you pursue your degree here. Fees are about $500 per year. Full-time students at Northeastern have to have health insurance. It's a legal requirement for the state of Massachusetts, and that's about $2,100 per year. So for 2 years, start pursuing your degree in Northeastern University in Boston. Sometimes we use a total figure of around $70,000 or $80,000 US to complete your degree. So that includes tuition costs, all of your academic costs, and also your personal costs, rent and other accommodations. So you can see it's a significant investment of time and energy and money. But engineering professionals, just like other professionals like physicians or attorneys, invest heavily in their education and their personal development, professional development, so they can advance in the professions. And so our students make that investment to experience the return on the investment, getting the career and the job that they want, developing knowledge and skills, and benefiting from all the linkages to the field that our faculty can provide, that the cooperative education program can provide, that the Gordon Institute for Engineering Leadership can provide. Most of our Master of Science level students at Northeastern University fund their education entirely through the use of personal and family funds. I've seen a lot of students taking out educational loans that support their pursuit of their degree. The Cooperative Education Program allows hundreds of students every year to pursue industrial paid co-op positions. Students can earn a significant salary to defray education costs, but it is a competitive program. Not all students that want a co-op position will be successful in getting a co-op position. So, but those that do can defray a significant percentage of their educational costs. Most students, including international students, are able to find part-time work as they pursue their degree. I've spoken anecdotally to a number of our international students. Many of them are successful in getting part-time work. And all applicants to our programs are actually automatically considered for partial tuition scholarships. They're very difficult to get. They're awarded to the top 3% of our admitted class. And the vast majority of our students don't receive any type of financial assistance from us, but a few lucky students will be awarded some type of partial tuition scholarship. It's a situation where you'll be automatically considered and you'll be notified if you're awarded, but you won't be notified if you're not awarded. So once again, you're automatically considered, but most students will finance their degree entirely on their own, much like other professionals, as I've said. Okay, so we're towards the end of our talk today. Let me put my microphone on mute for a second, and I'd like to ask you to think about what your questions might be for Professor Metghalchi, for Laura Meyer in the co-op program, or for myself in admissions, and we'll see if we can facilitate a bit of Q&A this morning. So I'll go on mute here for a second, and we'll be monitoring our chat window to see what questions you have for us today. Okay, Professor Metghalchi would like to address you again.
Hello, everybody again. So to review what we've done for this program, we have a Master of Science in Energy Systems of Engineering, which is unique in the world. There is no other program comes close to what we have, and let me tell you why. The curriculum is a wide open curriculum. You deal with the technical courses, you deal with the finance course, economics course, public policy course, and other stuff that you're interested in. We have a cooperative education, so we do our best to find co-op job for anybody that who is interested to go to co-op, to spend 4 to 8 months in the industry. Many students also find themselves those kind of jobs, but we're trying to get it as much as possible. We have the leadership program, Gordon Leadership Program, and that's again unique. You take courses in the leadership, you do a challenge project with industry, and the challenge project with industry should involve you developing a new design of something in which it has to be better than whatever exists locally, and it has to economically make sense. That is, there has to be market analysis to make sure that you can sell the product, and also it has to include some leadership version into it. The Gordon Leadership Program is run by the Institute, and they connect you to local industry to figure out what the challenge project should be. And then at the end, we're in Boston. It's a nice place to be, and it's a city of youngsters. We have over 50 universities in the Boston local area. So for all these reasons, that's why I'm saying we have the unique program that does not exist anywhere else in the world. Okay, I think we're back to Mr. Engel.
Okay, we've had a couple of questions pop up on our chat window. One's for Dr. Metghalchi, and one is for me in admissions. Someone asked that they applied for spring 2018 entry, and they haven't received their decision yet. We'll be releasing decisions on or before mid-October timeframe, so you'll hear about your official status regarding your application, regardless of what program you applied to, by October 15th timeframe. So we wish you the best of luck. Our faculty are working hard to review applications as we speak. You'll be hearing from us very soon. We hope that you look forward to receiving your official decision, and if you're officially accepted, we hope that you're looking forward to joining us this particular spring. Okay, so a technical question for Professor Metghalchi. We have today asking a question about courses within the program and or research related to smart grid.
Okay, you can take one of the elective courses, we call it a project. The way you figure out the project, you take the required courses, and you possibly, if you're dealing with smart grid, that means most likely you're an electrical engineer. You take a course or two in electrical engineering by the professors who are doing research in power. Then after you finish the course, you go back to the professor and say, Professor, I want to do a project for you, equivalent to one course, and hopefully your grades are very good in the courses that you've taken with the professor, and usually that works out and you deal with the professor on that project. The program does not require research, so it's all courses, eight courses that you take, and as I said, it makes you ready to go to industry. If you want to do more research then you have to take elective course, substitute elective courses by project and research, but that's not required in the program as of right now.
Okay, thank you for that response, Dr. Metghalchi. Let's see what other questions that we have from our participants today. Okay, a couple more questions from our participants today. One is someone asked about the GRE verbal. We talked a bit about the admissions, the criteria that we look for applicants to be competitive for acceptance into this program. As Professor Metghalchi mentioned in his talk, we put more emphasis on the quantitative score, so we look for quantitative scores around the 61st percentile. But if a candidate shows other strengths in their background, particularly if they have related work experience, sometimes they can still be admissible to the program. Question about the GRE verbal and the analytical writing. Those are not considered strongly in the admissions review process. So we don't have particular standards related to the verbal performance and analytical writing. So we really look for a candidate that has strong quantitative skills, either evidenced by the GREQ performance or by a very good academic achievement in your program of study. Okay, we have another question from one of the participants today talking about or asking what can they do now to prepare for the program in the future, or if there's anything that we would recommend that students do to prepare academically for the program. So I'll ask Professor Metghalchi to respond to that question.
Well, this is a very general question, and it's impossible to answer correctly, but we need some background in mathematics and thermodynamics because that's where the energy comes in. So if you have time to improve your math, review your math, and if you've taken a thermal course, review it. If you haven't taken it, if you have possibility, take a thermodynamics course. But to answer you, give you a better answer, I really need more specific of your background So what courses have you taken? What is your major? And then I can do a better job at recommending what to do next. Therefore, I ask you to send me an email. The email address is on this last slide. And that's also true for all of you. Any question you have, just send me an email, and we communicate through email, I think would be easy, because some of those questions are specific to you, and if I don't know your background, it would be hard for me to respond to it.
I'll add, Professor Metghalchi, that if you apply to the Energy Systems Program, and if the admissions committee officially accepts you to the program, then you're prepared to begin the Energy Systems Program. So you've already done the hard work of submitting your application. Once you're officially accepted, consider yourself fully qualified to pursue the program of study. Okay, everyone, it's just a couple minutes before the hour. We want to end on time today. And so in the interest of time, we'd like to conclude our session. Let me ask Professor Metghalchi if he'd like to say any concluding statements.
Well, thank you all for being with us for an hour. It's almost impossible to give you the whole picture in an hour. We do a lot of different things. The Energy Student Organization, they do amazing work, and then of course we have co-op and leadership. So if you feel like you need more information, communicate with us, and we make sure that you get all the information correctly. And hopefully you're qualified, you apply, and we'll see you soon in Boston.
Thank you, Professor Metghalchi. Let me remind everyone today that we recorded our session today, so if you missed anything important, we'll send you a link to this recorded session. Once again, we appreciate your interest in the program. If you have questions, please send Professor Metghalchi an email. Also visit the URL on our last slide here. This is a new site that's been created to pull together all the important information that any prospective student to our programs would want to see. So thank you for joining us today. We hope you learned a lot. Have a good rest of your day. Goodbye.